Welcome to the Breaking Lab Barriers webinar, a unified solution for test automation and lab management. In this webinar, we will discuss how the combination of test automation, lab management, and proper driver creation maximizes test lab performance during test equipment upgrades and replacements. Quali Systems is an international software company. We have offices worldwide and different channels. We've been founded in 2004. The product we generate is a pure software called TestShell. It is a complete automation framework. The idea is to automate hardware and system environments, similar to how Mercury has affected software environments. Our president and chairman are both ex-Mercury leaders and drive the company today to bring it to the same success. We have a wide variety of customers, from flash and chip manufacturers like SanDisk, Broadcom, and CSR, to different network equipment manufacturers like Cisco, Ceragon, and RUD, and all the way to service providers like Deutsche Telekom, Telstra, and Vodafone. The list goes on and on, but what all of them have in common is the same pain of testing and time to market. The value that our product provides at the end of the day is improving product quality, shortening time to market, and reducing expenditures. All that while keeping up with compliance and audit trails that are required in different environments. In a test lab, our goal is to test, whether it is a device, a setup, or a service. We always have to deal with test equipment. Traffic generators, network emulators, network monitors, physical layer switches, and many other kinds of equipment that we can find in different labs. So how do we maximize our lab's performance when we automate tests? First of all, we may have to make sure that we control the entire lab, including the systems under test, the interconnects, and the test equipment. Second, we have to make sure that the tests we create are robust enough so they don't break when we change the equipment. And finally, we have to optimize equipment utilization. Controlling test equipment is a large part of test automation. We can communicate devices directly, for example using CLI, or via drivers. We could use drivers provided by the vendor, or create custom drivers, which require programming. Automation may use different interfaces, network protocols like Telnet, SSH, or SNMP, software interfaces like DLLs and executables, scripts like Tcl, Python, and Perl, or drivers. Let's take a look at an example. I have a test scenario that requires controlling an operational support system, which has to be done by GUI automation. I also have a Telabs multi-service router, which I can control via Telnet, and a couple of traffic generators that I can control using different drivers. In order to automate the entire scenario, I need to be able to control all this equipment. Quali Systems TestShell allows automating the different pieces of equipment under one standardized framework, using a wide range of wizard-driven interfaces. It also provides a long list of built-in drivers, so connecting to equipment is quick and easy. TestShell has been used to automate various pieces of equipment and devices. Among them are Ixia and Spirent traffic generators, Layer 1 switches, Cisco equipment, sniffers, Alcatel-Lucent business and operational support systems, and this is just the tip of the iceberg. So we have the first point covered. We managed to quickly control our entire lab and create automated tests. Now we have to take care of the second point. In today's fast-paced environment, equipment aspects frequently change. For example, equipment is upgraded. I get a new blade, a new software module, and so on. I can also switch vendors or simply want my test to run on different stations, first in the lab and then in the field. So I managed to control my equipment, and it understands my automation commands. But what happens when the equipment aspects change? How have we coped with this in the past? Well, we mainly had to rewrite or update our automated tests. If we were using custom drivers, tedious maintenance was required. And of course it requires programming skills. And the ability to make changes depends very much on the quality and architecture of the driver. This is exactly what it sounds like, a big effort taking time and resources. And it could bring you to think, is automation really worth it? TestShell overcomes these challenges. We already talked about the wizard control interfaces and the built-in drivers, which allow to quickly connect to equipment. In addition, TestShell overcomes equipment changes by adding functionality to existing drivers and allow you to create your own drivers from scratch. This is done with a user-friendly GUI that allows even non-programmers to join the automation effort. Of course, programming skills enhance the solution, but even if you don't have any, you can still write automation. The drivers are designed to support full equipment interchangeability and high-speed performance and implementation. Let's see how it's done. Say that I have some piece of equipment in my lab. It has functionality A, B, C, D, E. I can use this functionality to create a driver that converts the functionality into simple automation commands that the test engineer can use to create test automation. Now the equipment is upgraded. I have a new functionality F. TestShell allows me to create new automation commands that use this new functionality. And the nice thing is, since the 4 commands that I had didn't change, my tests still work. We will see a demonstration of this in the demo later. So we covered the second point. Our framework is robust enough to handle equipment changes, and our tests don't break. Now we have to increase equipment utilization. Test equipment cost is high, so we want to utilize it as much as possible. In addition, trying to share equipment between multiple teams or labs is difficult. For example, let's say that I have 2 test teams that use the same traffic generator. The manager doesn't want any conflicts, so he lets one team use it for 2 days, and then the other team gets it. The first team runs a test that should take 2 days. The test runs, but at the end of the 2 days it needs 10 more minutes to go. Unfortunately, the other team doesn't know that, so they take over the equipment. 2 days of work are gone. When the manager hears about it, the conclusion will probably be that a bigger buffer is required, so each team will get a traffic generator for a week. The result is that equipment utilization often drops to as low as 30%. Another thing is, we have test automation and we want to make it the best out of it and run tests over nights and weekends. And in the management level, we want to be able to allocate equipment and track what happens with the equipment and how it is utilized. TestShell's solution to increasing utilization is a client-server logging service with a scheduling service that has an Outlook-like interface. Since this is all part of one framework, you get full exposure and integration with the test automation application. The result is that more people can share the equipment more often. You can execute your tests and regression 24/7, and you can easily allocate equipment and see how it's used. So we managed to cover the third point as well. Going back to the big picture, TestShell provides a complete framework for test automation. We begin with creating the automated tests and regression, easily connecting to any device in the lab. It is also possible to independently upgrade or create equipment drivers. We then move to executing the test we have created. Automation becomes even more powerful when we schedule testing, filling empty slots nights and weekends. The management part of the framework makes sure we don't step on each other's toes. The testing results are saved in the central database. The result of every executed test and regression is saved and can be reported immediately. The framework allows analyzing the aggregated results and viewing online reports, trend graphs, and dashboards via a web interface anytime, anywhere. Okay, so let's move on to our demo, and I'll just explain what we're going to see. Our demo is going to show how we manage lab equipment and define topologies, and then how we easily interface with the test equipment to create automated tests. We'll see how we can schedule test resources, and how we can modify a driver when equipment is upgraded, and how we make sure that our tests are robust enough and don't break. So let's watch the demo. In this demo, we will see how TestShell helps optimize your lab management. We will use the example of Jane, a test engineer who works for a telecom service provider. She has to create a test scenario for service provisioning. It begins with configuring the required services on the operational support system, then starting the traffic and making sure that the end user is provided with the service. First of all, Jane goes to the TestShell Resource Manager. On the left, all the equipment in the organization is managed, including systems under test, traffic generators, servers, layer 1 switches, and the different topologies used in tests and regressions. The topology Jane is going to use doesn't exist yet, so she has to create it. She adds a topology, drags the Telabs multi-service router, the Ixia traffic generator, and Aspirant. The equipment is already connected to the layer 1 switch. All she has to do is define the required ports and click on Calculate. Since Layer 1 switch control is embedded in the Resource Manager, the path is calculated automatically. Once this is done, the topology can be used in tests anytime. Jane can now create her test scenario. She goes to TestShell Studio and creates a new test under a Labs folder. The first step in the test is to reserve the topology she has created, so that when the test runs, the topology gets locked. The next step is to automate the service provisioning on the operational support system. The OSS can be controlled by Telnet or by web. Jane already has functions for both options that she and her teammates have created and can reuse in tests. She chooses the web function. Once this is done, she drags the Spirent Test Center built-in interface to her test. Diving into the driver, Jane can see the automation commands available for the Spirent Test Center. She simply has to add them to the sequence in order to automate the traffic generator. Jane wants the Ixia to run in parallel with the Spirent traffic generator. She drags a parallel step and the Ixia built-in interface, which is created similarly to the Spirent. She then adds another step that parses the statistics received from the traffic generators and a test pass-fail criteria. The last step is deactivating the topology so other people can use the equipment. The test scenario is done, and one of the options is to schedule its execution in the test shell scheduler using the Outlook-like interface. The test runs perfectly and everything goes well for a few months, but then Jane's boss comes over and tells her that a new Ethernet OEM module was purchased for the Spirent Test Center. The new functionality has to be available for everyone to use in their tests, which means the driver has to change. The driver can be easily modified in Test Shell Driver Builder. Here's the list of functions available in the current driver. Jane has to add a new set of functions for the Ethernet OEM module. She begins with the Ethernet OEM Start Continuity Check. The first step in the test is initializing the parameters. The next step is to communicate with the Spirent, and this is done, in this case, with a Tcl script. It can also be done with any network protocol, software interface, or script using the wizard-driven GUI. The last step in the test is logging the data. The function is now complete. The rest of the required functions have to be implemented the same way. Once the entire set is created, one click and the driver is compiled. It is now possible to deploy the upgraded driver. This is done in Test Shell Shared Resources. The driver is immediately deployed and ready for everyone to use in their tests, and since the old functions are not changed, there is no need to do any test redesign. In this demo, we saw how Jane was able to create her topology in minutes. She was able to connect to all the required pieces of equipment very easily. She also used building blocks that she and her teammates have created. She could therefore have her tests up and running in no time. Then she could schedule the execution without being worried of conflicts with other people who use the same equipment. Finally, when the equipment was upgraded, she was able to add new functionality to the driver, compile it, and deploy with minimal effort and without breaking existing tests. We saw how combining test automation, lab management, and driver creation and modification maximized test lab performance, saving Jane and her organization time and effort. To summarize, I would like to review the key benefits we saw in the framework. First is the quick integration with equipment. Whether it is through the wizard-driven capture replay interfaces or the built-in drivers, controlling equipment is fast, so you get immediate value. Reusable building blocks make controlling equipment even easier once you or someone else in the organization already has the required assets in the shared repository. Optimized utilization is enabled using the central reservation and scheduling. Test Shell allows test team and labs to share equipment efficiently and take full advantage of automation by executing at nights, weekends, and empty slots. Since it's all under one framework, everything is integrated and accessible. We also saw that minimal effort is required when equipment changes. It is possible to update existing drivers easily. Sometimes it is possible to perform abstraction of equipment, and when changes are made, the updated drivers can be immediately deployed in the shared assets. And if the change still requires updating tests, they are standardized and easy to maintain. Finally, Test Shell allows more people to join the automation effort. The friendly GUI and wizard-driven interfaces allow non-programmers to create automated tests. Complex vendor-specific commands can be turned into automation commands that test engineers can use in a standardized framework that everyone is familiar with. And knowledge and asset sharing is made easy. With more test engineers involved, robust test creation, and better utilized equipment, it is much easier to meet the test lab challenges and make our investment in automation worthwhile. Thank you for joining us.